In this video, we're going to find a few derivatives and talk about what rules we're using to find them. So our first function is p of r equals 4 times the square root of r to the 6th plus 2e to the r. Now, a lot of times with radicals, when we do derivatives, first thing we'll do is rewrite them as an exponent. So that's going to be r to the 6th plus 2e to the r to the 1/2. So we're going to have a chain rule because we can see the composition. So when I go to find my p prime of r, first thing I'm going to do, my exponent's on the outside. This is the inside function. So when I apply the chain rule, I'm going to do the derivative of the outside. So my 4 will stay out front. Derivative of the outside, I bring the 1/2 out front, 1/2. Leave the inside alone, r to the 6th times 2e to the r. Decrease the power on the exponent by 1. And now I'm still going to have to take the derivative of the inside, 2e to the r. That's going to be able to be done piece by piece. So let's see what we can do. Well, this will simplify. 4 times 1/2 is 2. R to the 6th plus, excuse me, that should have been a plus the whole time, plus 2e to the r to the negative 1/2 times. This derivative we're going to do piece by piece. Now we have a power rule. 6r to the 5th, and an exponential rule, well, that function is its own derivative, 2e to the r. If we wanted to, because of that negative exponent, we could put that in the denominator under a radical, so on top we'd have the 2, and then this piece here, 6r to the 5th plus 2e to the r, all over the square root, because it's a 1/2 power, r to the 6th plus 2e to the r. Nothing we can really cancel, so that's about as simplified as we're going to get. Let's go ahead and try one more in this video. So let's say we have the function m of v equals sine of v squared cosine of v cubed. So you're probably identifying the compositions. There's a composition here and a composition here. But the overall structure is a product. So as we go to set this up, the first thing we're going to do is set it up via product rule. So m prime of v, and we'll use a little extra notation just to make that clear. We're going to hold the first part constant, so sine of v squared times the derivative with respect to v of cosine of v cubed plus cosine of v cubed times the derivative with respect to v of sine of v squared. Okay, so you can see the product rule form in here. Now we'll take those derivatives. These derivatives are going to require chain rule. So we have sine of v squared, because that was left alone, times, this is a chain rule. The outside function is the cosine, the inside function is the v cubed. So first off, the derivative of cosine is negative sine, leave the inside alone, v cubed, times the derivative of the inside, so the derivative of v cubed is 3v squared. So this part here is the derivative of this guy, plus cosine of v cubed. Now we're going to do the derivative here. It's going to be similar to this. The outside is sine, the inside is v squared, so the derivative of the outside is cosine, leave the inside alone, v squared, times the derivative of the inside, which is 2v. So this part here is the derivative of this piece. There's not going to be a ton of simplifying we could do. If we wanted, we could factor a v out of the whole thing, and we can kind of condense this. Actually, not very much, because these have different arguments. So we'll have 3v, and it'll be negative, sine of v squared, sine of v cubed, plus 2 cosine of v cubed times cosine of v squared. Not much more we can do to simplify that, unfortunately. So that's about as nice as this one's going to get.